Hello everyone. In this video, we are going to discuss rule-based classifiers. By the end of this video, you should be able to understand how rule-based classifiers work, know the algorithms used to build them, and evaluate these classifiers using some performance metrics. Unlike the other black box models, rule-based classifiers represent knowledge as if-then rules, making every decision making highly explainable. That's why they are heavily used in healthcare and finance, where transparency is non negotiable. Let us see what is a rule. A rule has two parts, the antecedent or the if part, which holds one or more conditions joined by AND operator, and the consequent or the then part, which holds the prediction label. An example rule is if age greater than 18 and income greater than 50,000, then label equals high value. A rule set is a collection of such rules formally expressed in disjunctive normal form, meaning it's a set of rules joined by OR operator. Each individual rule is a conjunction of conditions that maps to their class label. So the classifier fires whichever rules conditions are satisfied by the input record. The classification model works by checking each test record against the rules. A rule covers a record if the record satisfies the antecedent condition. And when that happens, we say the rule is triggered and the consequent class label is assigned. But there can be two problems. What if multiple rules fire for the same record? And what if no rule fires for any record? We will see how to address this in further slides. To handle these edge cases, we define two desirable properties of a rule set. First, mutual exclusivity, meaning no two rules should cover the same record, ensuring there is no ambiguity. Second, exhaustiveness, meaning there should be a rule for every possible record, so no input goes unclassified. In practice, rule sets may not always be exhaustive or mutually exclusive. To address exhaustivity, we add a default rule, a rule with no antecedent conditions that simply assigns the majority class label to the test record. For mutual exclusivity, we use two strategies. First, ordered rules, where we assign the class of highest priority rule among covering rules. Second, unordered rules, where all covering rules vote and the majority vote determines the final label. Now, to measure quality of a rule, we use two metrics, coverage and accuracy. Coverage tells us what fraction of the dataset the rule applies to. Accuracy, also known as confidence, tells us how often the rule is correct when it does apply. Looking at our example, the rule covers 4 out of 6 records, giving a coverage of 0.67. And out of those 4 records, it correctly classifies 3 of them, giving an accuracy of 0.75. Together, these two metrics help us assess the rule quality. There are two types of methods to build a rule based classifier. One is a direct method of sequential covering algorithm, and the other is an indirect method using decision tree. Sequential covering algorithm generate rules directly from data. We start with an empty rule, grow it using learn one rule function, add it to the rule set, and then remove the records it covered. This process repeats until all records are covered. The learn one rule is a greedy method to define a rule using pruning based on chosen metric. It has two strategies, general to specific and specific to general. In rule growing, simple metrics like accuracy or coverage can be misleading. A rule may look accurate but cover only a handful of cases, while broad coverage can also be deceptive because a rule could be random also. That's why we use likelihood ratio statistic. It measures how much more likely a rule is to appear in the target class than in non-target class. This ensures we refine rules that truly separate positives from negatives. It is helpful when classes are imbalanced. The indirect method utilizes an already made decision tree to extract rules. Rules are made such that every path from root to leaf node can be directly translated into a rule. This is a great method because rules made that way are already mutually exclusive and exhaustive because every leaf has a unique path from root. And with this, we conclude with our topic of rule based classifiers. Thank you for watching.